Good morning everyone. My name is Professor Vijay Travadikar. I am president in the Mechanical Department, Ushiramji Gaikwad Patil College of Engineering. Today we will discuss about the gyroscopic couple which is act on this machine. Okay. Now this gyroscope, this is the demonstration in the practical lab taking place with the help of different weights. Now this is the rotor. Rotor is having a 300 mm diameter. Now the axis about which this rotor rotates is called as axis of spin. Whenever this rotor rotates and the force will be applied on this, it will take a turn, left turn and right turn. To control the orientation of any vehicle, this gyroscope has to be installed or implemented on the vehicle. Particularly, these gyroscopes are installed on a ship, aeroplane, four-wheeler, two-wheeler to control the orientation of the vehicle. Now, this rotor is rotated at a different speed. Diameter of the rotor is 300 mm and this is the axis of spin about which the rotor is rotated. Whenever the force is applied on this end, it will take a turn. Now see the turn. It may take a turn on the left hand side or it may take a turn on the right hand side. Now this is the turn on the left hand side and this is the turn on the right hand side will provide an axis of precision. With this turn, a vehicle, ship, four-wheeler or two-wheeler will take a turn. Means the axis about which the vehicle turn is called as axis of precision. If precisely, now this is the axis, this is the rotation of vehicle, this is the rotation of the vehicle, and if you want to calculate about which this vehicle rotates, now this shaft will be the axis of precision. Axis of spin will be the horizontal one, axis of precision will be the vertical one. Now with these two axes, there is a third gyroscopic couple which is act. Now this gyroscope, as soon as I put the pressure on this one, means the force is applied. Active couple will be act on this gyroscope and it will be taken. My intention is that to take a turn, but with the application of this active couple, with the active force, this vehicle will move above or below. See here, now this, as soon as I put the finger here, this gyroscope will take towards the upward side, means the nose will be upward and the tail will be down. This is happened just because of the application of gyroscopic couple. Application of gyroscopic couple. Let us check how to calculate the active couple and how to calculate the reactive couple. Active couple is so simple. I just put a weight here, means I am putting the weight here. As soon as I put the weight here, this is the rotor having 300 mm diameter and I start the machine. Now see that the active couple will be act on the gyroscopic just by the application of 200 grams. 200 grams of the weight is at a distance of 20.1. See this distance. This distance is 20.1. This distance is 20.1 away from the CG of rotor. So if you calculate the moment of inertia of a rotor, the mass of the rotor is 6.63 kg. Diameter of the rotor is 300 mm, and if you calculate the value of moment of inertia of this rotor, it comes out to be I is equal to half m r square, where half m is equal to 6.63 kg, the weight of this rotating rotor, and radius is equal to 300 rpm or 300 mm. So the moment of inertia of the rotor becomes 0.072 kg meter, and you can easily calculate the reactive couple and the active couple just by using this moment of inertia. So what should be the applied force? Applied, as we know that twist, moment of inertia and the torque are almost same. So what is the torque which is applied? What is the active couple which is applied on this gyroscope? Let us calculate. Now the moment of inertia we have calculated at 300 mm and at 6.63 kg, it comes out to be 0.072 kg meters. So let us calculate the active couples, which is couple or the torque, which is nothing but the force into the distance. Okay, now this is the force and this is the distance from the disc. Let us calculate this one first. Okay, now I have put a weight on this gyroscope element where we calculate the active couple. This weight is put at a distance of 20.1 centimeter away from the CG of the disc. Weight into distance, this is the weight and this is the distance, will give active couple which is X. This is the theoretical calculation. We can easily calculate, we can measure this weight, we can measure this distance, and we can calculate a theoretical active couple which is X on this gyroscope. If you want to calculate the practical active couple, practical reactive couple On this gyroscope, what we have to do? We have to calculate by using the formula, which is reactive gyroscopic couple is equal to I into omega p, where I the moment of inertia, which is already calculated. It comes out to be half mr square, where m is equal to mass of the rotor 6.63 kg, radius is equal to 150 mm, and the moment of inertia calculated as 0.072 kg meter. Now what is remaining in the reactive gyroscopic couple? As we know that the reactive gyroscopic couple is equal to C is equal to I, which is known now, omega, which can be calculated, which is the speed of the rotor, speed of the disc, and omega p is the speed of the rotation. So let us how to calculate the omega. Now omega is calculated by using this tachometer. Now this rotor is rotating and we can calculate the speed. Now this is the value of omega of the rotor. It is around 1024 RPM. See here, average speed is 1024 RPM. 1000 RPM is the speed of this rotor. Means the value of omega is equal to 2 pi n by 16. So n becomes 1000. We can easily calculate the value of omega 2 pi 1000 divided by 60. R is known, omega is known. What is left? Omega p. How to calculate omega p for the practical demonstration? Let us see. Now see that I have removed this weight from the gyroscopic element. Now I have to calculate the value of omega p, means the angular velocity of the procedure of this gyroscope by taking a turn. Now this gyroscope is taking a turn toward the right hand side. Omega p in the real time can be calculated as d by r, where v is the velocity of the vehicle and r is the radius of the curvature. Because if this gyroscope is implemented or installed on the vehicle, the velocity of the vehicle can be easily calculated, and the radius of the curvature we can easily calculate by taking a left turn and right turn. But for the practical demonstration, we cannot calculate omega p by using d by r formula, linear velocity. This gyroscopic element does not have a linear velocity. It is voltage. So omega p can be calculated by using the formula d theta by dt, where theta is the angle turned by the gyroscope for the particular time period. Now as soon as I put the weight here, this gyroscope Just I will measure the angle for 10 seconds. Omega p is equal to d theta by dt. I will measure the angle for 10 seconds. How much turn will be take by this gyroscope for the 10 seconds? I will stop the start one where I will calculate the angle turn. Now this is the angle. Here now see that indicator, see that difference the indicator, we can measure the d theta for the 10 seconds. Now without the application, this one is taking the turn. We can measure the turn for the 10 seconds by applying a weight. Now I am applying the weight here. As soon as I put the weight here, I will start a stopwatch for the 10 seconds and I will measure the angle for the 10 seconds. Okay. Now this weight is applied here. Okay. I will start. Weight is applied here. I will start stopwatch. Now I will for the 10 seconds. Initially it is 240. It is taking a turn for the 30. Okay. For the 10 seconds, 30 and 30 band for 400 grams. Okay. I will put out this weight. I will increase the weight 600 grams. Again I will calculate the omega p d theta by dt. Means I have to calculate that one for 10 seconds. Again I will put the value 600 grams for 10 seconds. I have started for the 10 seconds. It will around 40 degrees. In this way, at every change of weight, we can measure the value of angle taken by this gyroscope. Gyroscope is taking a turn, means vehicle is also taking a turn because this gyroscope is installed on a vehicle. Once the omega p is equal to d theta by dt is calculated. Now d theta by dt is known, omega is also known, I is also known. So reactive gyroscopic couple becomes C is equal to I 0.072 meter, omega 2 by n plus 60 and omega p d theta by dt. Take the average value of d theta by dt and calculate the reactive gyroscopic couple and compare this reactive gyroscopic couple with the active gyroscopic couple that we have already calculated at initial stage just by applying the weight. It is weight into this distance will be the active gyroscopic couple and during the demonstration we have calculated the reactive gyroscopic couple. And let us compare the active gyroscopic value and the reactive gyroscopic value and let us check that what is the difference and we can come to the conclusion that what is the difference in the value of active gyroscopic couple and the reactive gyroscopic couple. In this way we can calculate, compare the active gyroscopic and reactive gyroscopic couple in the practical way. Thank you very much.